Hello, this is the live stream for electric vehicle. Okay, so this event is purely engineering, so there's no testing at all. You have to build a car that goes in a curved path to target, and what this means is there's two cans, and you have to go between them, and they're off to the side of the center line. So you have to go in a curved path to go to the center target. And this target would be about 9 to 12 meters away, and they tell you the distance at the competition, so you don't actually get it beforehand. You have to you have to change the code or some variable in your vehicle at the competition to make it travel different distances between 9 and 12 meters. Um, the competition has two runs. You get 8 minutes to do both runs, and you get the best score out of both runs. And lastly, your car has to have a wooden dowel, which is 20 centimeters tall and a 1/4 inch thick. This is actually crucial because they won't let you, they'll dock you off penalties if you don't have this. And what it does is it triggers the photogate sensors, which measure your speed. The two things that are considered to get points are speed and how close you are to the end target, and also the bonus you get by going through the cans. So, like I said, the electric vehicle has to go between two bonus cans. One of them is going to be 1 meter to the right of the center line. In the center, between, like, if it was 9 meters, it would be at 4.5 meters. And um, the second can, your team gets to place. And the closer that you place, or the farther that you place the can from the center line, the less points you get. So you want to place it as close to the center line as possible for the most points. This also means that you have to that you're more likely to hit the cans. So you have to make sure that you can precisely and consistently curve your vehicle to go between the two cans for bonus points. And it's bonus points, but pretty much all of the top 5 teams are going to do it. So it's not really bonus. You kind of have to do it if you want to do well. Um, some other parameters: the batteries have to be under or equal to 9 volt, and you can't use mechanical power. So you can't wind up a spring and use that to propel your vehicle. You have to use a battery and a motor, and it also has to fit within a 30 by 60 centimeter square. That should be pretty easy because 30 by 60 centimeters is definitely large enough for you to fit a small vehicle in. Here is a video of an example electric vehicle. So this one is moving back and forth to reach the finishing point, but for this year's electric vehicle, you're not allowed to do that. So you can't use an encoder to measure the exact distance and move forward and back. You can only move forward in this year's challenge. Yeah. Okay. So the most points are achieved by getting no penalties, going through the bonus scans, and going the fastest and most accurately to the target point. So, however, speed is not the main consideration. You have to consider all of these things, and accuracy matters just as much as speed. I can't emphasize that enough. If you go really fast but you land 2 meters away from the target, you'll do just as badly as if you land right next to the target and it takes you 20 seconds to go 9 meters. Ideally, you'd want to go the 9 to 12 meters in approximately 7 seconds or less if you want to do well. The top teams get as low as 2 seconds, and the worst teams usually get about 10 to 15 seconds. Um, And for basically, remote control is not allowed for this event, so you have to press a button on your vehicle to make it go. And this is using a pencil. You press a button using a pencil, and that has to make your vehicle go. So you can do that using a push button with Arduino, or Arduino is a microcontroller that many teams use to control their device. Or you can use Legos. You can use a Lego button. Yeah. So for the brain of your device, like I said, you can use Arduino. This is an Arduino Uno. Um, it's actually what most teams use because it's pretty versatile and you can do a lot of things with it. So, um, for example, a push button, you just have to wire it to a breadboard. It's pretty straightforward. You can just look up a tutorial online. If you're really good with Legos, you could use NXT, but I don't recommend it because NXT is extremely heavy and also it just it's not very accurate either. Like you can't control your left and right and forward distance that accurately. And even if you can, it's very, very slow, and you'll basically get docked off a ton on that. For the body of your device, you can either use um, an RC chassis, which you can buy, or you can make a chassis out of wood or a polycarb or something with machined parts. And you can also use Legos. Legos is good for the chassis itself, but for the actual motors and controller, it's just very, very heavy. So a few things to consider. You need to, so if your device is going really fast, you need to brake your device um, as it reaches the finish line. So there's a few methods to do this. You can use a limit switch, which detects when you've gone a certain distance, and then reverse the motor direction to make your vehicle slow down. Or you can have a physical braking system that presses against the wheels. Another thing to consider is how much is your device going to cost. The MVHS Scioly doesn't have that much money. We spent a lot of money on robot arm and electric vehicle last year, and we want ideally we want it to cost less than like $50 to $75. If you already have a Lego kit, it won't cost anything. But if you think you really have a design that's good and it will cost a decent amount of money, but you know you can win um, first place or top five at least, then you should invest in that design and try and do well in the interview so you can get on the purple team. Yeah, like I said, they give you the distance at the competition, so you have to have some element of programming or something to change the distance that your vehicle travels. So, for example, if you're using Arduino, you can upload some code to the microcontroller, which changes the amount of distance that your car goes, depending on the distance they give you at the competition. So now that you know what electric vehicle is, you should start creating a blueprint of your device. So in the interview, we're going to be basically checking your blueprint or some sort of drawing because we don't have a test, so we can't test you on anything, but we have to test you on how much knowledge you have and how much time you're willing to spend and things like that. So some resources are the resource portal. There's lots and lots of videos on YouTube of previous years competing in an electric vehicle. Um, how on Google you can find a ton of resources on how to build an electric vehicle, and I'll be putting more resources in the next few days on electric vehicle in the resource portal. Um, yeah. So now, if you have any questions, go. I'm going to the YouTube video, so comment them on the live stream. Oh, for some reason I can't find it. Okay, well, anyways, you can email me if you have any questions. My email should be either on the website or oh yeah, I'll also be emailing everyone the presentation, so you'll get my email from that. Okay, thanks for watching.